Okay, let's go ahead and understand how scope and duration works for class instance variables and methods. By the way, all the scope that you see for a class variable, an instance variable, works also for methods. Every method has scope. In other words, it can be seen in a certain area of your program. So I'm going to go ahead and create a brand new program, and let's save that as class scope. So I have three S's there. Actually, let's do an underscore just to make it a little bit more readable. Class scope.py. And the first thing I'm going to do is I'm going to put a person class. And there's my person class. And I have those instance variables. Now, the way this works is with an instance variable, it can either be public, protected, or private. A public instance variable means it's visible throughout the class and subclasses and outside of the class, like in the main program. If I went and created an object, said, oh, person equals person, oh, person dot first name equals Carlos. Whoops, sorry about the quote there. That is visible. And the reason this is visible is because it's considered a public attribute. Now, the reason it's public is because I said self dot first name. As long as I just said self dot and a variable, an instance variable, it's considered a public scope instance variable. It's visible in the class and it's visible outside of the class. Now, the next one we have is called protected. And protected variables, instance variables, say they are only visible in the class and any subclasses. So in the class, and if I did an inheritance, like right here, if I said class employee, subclass person, age would come down to that subclass also. So would the publics. But I shouldn't be able to access this protected variable outside of the class. Now we're going to have to learn something about how protected really works in Python. If I came over here and I just created a variable, oemp equals employee, and that is now an employee object. Let's just put the word pass there because I didn't do anything yet. So this object is of type employee, which inherits from person, which gets all the global attributes, and it gets the private attributes. Sorry, I had a misspelling there. Make sure you put the double E. So if I said oemp.firstname, it should be visible. Maria. And then if I said oemp.underscore age equals 20, this should not be visible. Now, this little underscore, that makes the attribute protected. You add an underscore, a single underscore before the name, right after the dot. This is now protected, and that says it should only be visible here and here. But in Python, you can actually still access protected variables outside of the class. And so what they do is they say, hey, yeah, that's protected in the class and the subclass, but would you please not try to access it outside of the class? We want everyone to be responsible and understand that if you have an underscore in front of a name, the scope is protected and you should not be doing this, but you can. So you just need to remember that rule, that if you see a protected, don't access it outside of the class or the subclass. You can, but don't. I could come here and I could create constructor, and here I could access it. Here I could say self dot underscore age equals some other value, and that's okay because the rule is you should only work with it in the class or subclasses. But just be careful, the scope isn't really truly a scope outside of that class. All the Python developers just said, we'll be obedient. Okay, that's protected. The last one to look at is now private. And here's how you do private. Self dot underscore underscore. Remember, a single underscore was protected. A double underscore equals private. And private says you're only visible in the class. You're not visible up here, and you're not visible outside the class. You're only visible in the class. Now, why would you care about any of this? Why do we care about scope of public, protected, or private? Well, let's say that there is something inside this class, and we really don't want people to access it outside of the class. We want them to come to the class. The class controls how they access it. And so if anybody ever really wanted to access that value, we could write what they call a getter and a setter. And the words don't mean anything, but we like to use them as a standard. Set underscore salary, receive a value, and then we're going to say self dot underscore salary equals F salary. So this now would allow the program over here to say omp dot set salary 55,000. But if you notice, I couldn't say omp dot a double underscore salary. It doesn't show up there. I can't get to it. That really works. The private says you are only visible in this class. Even though you don't think it's an error, if I ran that, it would blow up. So the way we want to access private value is we want to write getters and setters. A set method takes a value and assigns it to the private variable or the private instance variable, and the get, and make sure we put our self in there. Got to always have self. Don't forget that. We're going to return self dot underscore underscore salary. This is an example of a setter sets the value of a private instance variable because you can't get to it otherwise. I can't get to it outside of this class. So I have to use a setter, or I just don't let them get to it. Maybe I want to hide that. I want to encapsulate that. And a getter method gets the value of a private instance variable. And once again, this scope is the class. You can't get to it outside the class. This is not going to work. That's going to be an error. If I save that and run it, and I said Python class underscore scope dot py, we didn't print anything out, of course, so let's do this. Let's do a print right here of whatever. Oh, sorry, not on our setter. We only want to do that on our getter. So right here, let's do the omp.get salary, and let's print whatever it returns. Save it, run it one more time. Now you're not going to see the error here. Look, no error. It's like, wow, what's going on there? Well, if we did this again, and you printed another salary, let's see what it prints. That tells you you are not accessing the private variable. In fact, what you did is you actually just created a new instance variable on the fly, which is not good to do. We don't want to do this. We want to make sure we are only using instance variables that we've created in our class. We don't want to use the dynamic. The last thing I want to show you is what if we had another method in the person class. And in this method, we said full name, and then we said s full name equals that, and then we returned full name. Now, the one thing that we want to do, of course, before we run this is we want to give Maria a last name. So let's say omp.last name. Those are the public instance variable. and this will be Maria Gonzalez. And let's try to run this now. And it prints off Maria Gonzalez. Now, what happens here? Let's run this one through the debugger. I want you to see what happens. So we'll go to the debugger, run, and we want to set a breakpoint. We hit the breakpoint. Step. There's the employee constructor. There's salary, right? If I take a look in here, these are the different variables. Look, this is a function variable, full name. And that lives up there somewhere. Let's see what happens. We drop into here, we set the first, we set the salary. Here's where we're setting our private variable, set the salary. We then go to print the salary. And here's our self. This is the object we're working with. There's our first name, our last name. Those are the two public variables that came from the person class. Here's our OEMP object. Let's look at it. The OEMP has first name, last name. It has employee salary, but if you notice, you're not seeing that salary anywhere, that private variable. Let's see what happens. We come back to here. There's the private variable, but that's inside of that object. There it is. That OEMP object has the private variable, but I can't get to it outside of that class. It's within that class. Can't get to it. But there was a way to get to it if you use something called name mangling. Take a look at that. That's not just underscore underscore salary. That's called name mangling, where it takes private variables and it adds the class name in front of it with an underscore. This is a way that Python allows you to go and access data that is hidden or private or protected. And that means if I came back over to here and I said print OEMP dot, and I actually said, well, that's the object, right? How can I get to the attribute if I have the object? I want to try to get to that value. Well, what you do is you say the object, and then you say underscore, the name of the class. There's the class. And then double underscore the salary. Let's see what happens if that works. Oh, we're not going to be able to do that because we had the debugger running. So let's do a terminal window. We'll say Python, spelled correctly, space, class, scope.py. Look at that. You can access the value of a class variable through the use of name mangling. Name mangling. And what that means is you use the object dot, the class name with an underscore, and then the instance variable you're trying to get to that you probably shouldn't get to. So be cautious with this. Name mangling sort of breaks the rules of private and how it works. Public says it's visible everywhere. It's in the class, the subclasses, outside of the classes. Protected says it's visible in the class and the subclasses and shouldn't be visible outside the class, but it is, so let's be responsible. Private says double underscore, we're only visible in the class, not outside the class, so we can hide things from other users. But name mangling says you can still get to that. So be cautious with your scope. The scope says where the instance variable can be viewed, how long it lives, and also realize you can do the same thing with methods. You could set a protected or private method. There's a private method right there. Or there's a protected method. So you can add scope. The last thing I want to show you is what we call a class local variable. In this class person, we have a full name method. We set up sFullName to equal something. sFullName is what we call a class local variable, meaning a variable defined in the class, but in this case, it only lives for that function, just like a local variable. We're inside the class, but it's only visible in that class method. Once the method's over, that variable is dead. And that's a class local variable, a public instance variable, a protected instance variable, and a private instance variable. And like I said before, you could apply that same scope to methods. And we use scope so that we can hide data or share data. And we get to decide who gets to see what. A parent class can hide their data from child classes. If I did this on age, then any class that inherits from employee would not have access to that instance variable because it's private, and private only lives in the class. So this hides that value from subclasses and from the rest of the program. Once again, protected, visible in the class and subclasses, but not the program, and public, visible in the class, in the subclass, and outside of the class.